Okay, it's 4:45 and I'm going to see how quickly I can do the temperature measurement lab. We've got two transducers to deal with. One is a TMP36, and I've got this one right here. I've got it so that the positive line is red, the signal is orange, and the negative line is brown. So right now I'm going to plug the red line into +5. If I can find a hole that fits, and the brown line into ground. And I'm going to check and make sure, oh good, it's not heating up, so that means I got the power the right way around. And then I'm just going to stick one of the other pins into the breadboard here, just so that it's in a slot somewhere. So I've got power going to the TMP36, and I've got the signal coming out here, and I'm going to connect the signal to ground through a 10K resistor. That just provides somewhere for the current to go, and that'll take a little bit of the noise off the signal. So if I take my multimeter, I connect this lead to ground and this lead to the output of the TMP36 and turn it on. Then I should see the temperature of the TMP36. Now that's showing that I've got about 700 millivolts and it's dropping slowly. 500 millivolts is 0 and it's 10 millivolts per degree Celsius, so that's showing about 20 degrees Celsius. And when I squeeze it in my fingertips, it goes up to about 27, so that makes sense. So I think my TMP36 sensor is working. Now I've got my thermocouple here. I've plugged the red lead into the degrees Celsius hole and the black lead into the common. I've got the dial set to degrees Celsius and I turn on the power. And it says it's pretty cold in here, about 15 degrees. But if I squeeze it, it gets warmer. And if I let it go, it gets cooler quite quickly. So the thermocouple is fast. The TMP36, a little slower. Thermocouple cools down quite quickly. TMP36 takes quite a bit longer. So I've got both my sensors, they're both working. This one, the TMP36, is producing an output that's up close to 1 volt. It's about 0.7 volts or 700 millivolts. I could read that with my Arduino. This meter is telling me that I've got 16 degrees Celsius. If I switch it over here to DC voltage, well, right now it's telling me I've got 0 millivolts because this junction is at about the same temperature as those wires there. If I make it warmer, I get, maybe as high as 0.6 or maybe even 0.7 millivolts, but really a very small voltage. This is so small, I would not be able to read it with my Arduino. So I'm going to need some amplification to let me read it. So let's try a test now. Just a second, I'm going to need to get a cup and some boiling water. So here's my cup. I'm going to take the TMP36, I'm going to put it under the elastic band right there. Then I'm going to take the thermocouple, I'm going to put it under the elastic band just a little further over so that they should both be reading the temperature of the cup right now. Whoops. Thermocouple came out, so I'm going to have to be sure that it's in there. There, I think that might stay now. I'm going to stop the video while I wait for the kettle to boil. Okay, I'm back now, and I'm going to connect the output from the TMP36 sensor to the input A0 on the Arduino, just so that I'll have it going to the right place later on. So I'm back with the boiling water. Both sensors are still attached to the cup, and they're both reading about 15 degrees Celsius on the meters. And that meter just powered down because I wasn't doing anything with it, but I just powered it back up again. So here I go, pouring boiling water. Water in the cup. Thermocouple comes up quite quickly. The TMP36 sensor, it's coming up too, but not quite as quickly. Thermocouple's up to 56 degrees. TMP only up to 36 degrees, 37. TMP just made it to 50 degrees. Okay, I'm going to take the thermocouple out and just expose it to the air again. Let's see how quickly it drops back down again. Dropping down quite quickly. Was at 65 and it's now down almost to 35. It responds pretty fast. The TMP is just getting up to about 52. Doesn't seem to be rising anymore. So I'll take the TMP36 sensor out from under the wire there and just put that out in the air where it can cool off as well. Already it's dropping down, but it's dropping down more slowly than the thermocouple did. Thermocouple's almost back to room temperature. TMP36 down to about 36 degrees. So the thermocouple's coming down pretty quickly. And what if I stick it in the hot water? It shows that the hot water is actually about 74 degrees. So the water's hotter than we read on either of the other sensors. I'll take it out again and just put it back out in the air. It comes down pretty quickly. And now it's 2 minutes after 5. So I've just used up 17 minutes of my lab time. So there's pin 1 powered, and I'm going to plug that into +5. And then we also need to provide power to pin 2 so it won't stay asleep. So I'm going to plug pin 2 also into +5. For a common ground application, pin 3 needs to be grounded. That's the power supply ground, so I'm going to connect that to ground. And pin 5 provides us with a ground reference, so I'm going to connect pin 5 to ground. Now I'm sort of doing redundant things here because these little connectors here already made those connections, but you'll be using wires like these. Now in order for the amplifier to have a reasonable gain, I have to choose what resistance I'm going to put across there. This looks like a 56 ohm resistor. 60,000 divided by 56 is about 1,000, plus 4 gives me a little bit more. It's going to turn out that this is about 1,075 times gain. So the input that I put on pin 6 and pin 7 should be 1,000 times higher by the time it gets to the output over here. Now in order for the output to work, I need to connect pins 10 and 11 to each other. So there's pin 10 and 11 being connected with this yellow wire. I'm going to connect pin 10 to ground with a 10K resistor, so there's some load resistance to actually carry some current from the output. So let's have a look at what we've got. We've got +5, we've got ground, 0 volts, that's good. We've made our connections over here that we have to. We've connected the output that we have to, and we've given it a load resistance that its output can go through. And we've connected a gain resistor across here that should produce about 1,000 times gain. The last connection that we need to make right off is pin 12 needs to be connected to ground. So that was pin 11, so this is pin 12. And I'll connect it to ground. So now we've got the common ground amplifier all set up except for the inputs. Now on the inputs, I'm going to take, remember we had the thermocouple attached to this meter, and we had these red and black leads attached the same way. So I've got the thermocouple voltage on these red and black leads. So I'm going to put that into pins 6 and 7. I'll put a black one there and a red one there. So I've connected the thermocouple to the input. And let's see what we get on the output. There on pin 10. I'm getting a pretty big voltage. And if I squeeze the thermocouple, it's doing weird things. That's not what I expect it to do. The problem is that these inputs aren't in the middle in between the power connections, +5 and ground. They're floating somewhere at whatever voltage the thermocouple's at. So what I'd like to have them be is somewhere closer to 2.5 volts as their value. So up here I've connected 2 resistors. It doesn't really matter what magnitude of resistors, to 5 volts and ground. They're the same size as resistors as each other. So this value here is at 2.5 volts. I've got a 10 kilo ohm resistor here that I can connect between those and my inputs. So I'll take this 10 kilo ohm resistor and plug it in up here. So that 10K resistor I'll now connect down to one of the inputs. So let's connect that, whoops, down here to, say, pin 7. Could be pin 6, could be pin 7, doesn't really matter. Now I see that my output voltage here on pin 10 is pretty small, about 90 millivolts. And if I take the thermocouple and grip it between my fingers, oh, it's getting even smaller. And then maybe it's getting bigger again. I don't know. Maybe I've got these the wrong way around. Let's try my inputs the other way around. The high one on pin 6 and the low one on pin 7. If I squeeze it between my fingers, it goes up to a large value. If I let it out to the air, it starts dropping down. So remember, our thermocouple had a voltage that was in the millivolt range in actual voltage, and with our amplifier we've amplified that by more than 1,000 times to get it up into the volt range. So that's good. I'm getting a thermocouple amplified, and I'm getting a response. So now I'm going to take a connection from the output pins here, 10 and 11, and connect that to input A1 on the Arduino. And I should be able to read that voltage input there. Now by plugging into the 3.3 volt supply here, plugging that into the A ref pin, and then making my measurement on the 3.3 volt scale. So I think I've got everything working now. And it's 5:15, so it's taken me half an hour to get this far. I'm going to go boil some more water. So now I'm going to attach my sensors to the cup again. So now I got my thermocouple on there too. They're both in contact with the cup. So here we are again. I'm recording data on the Arduino, and I'm going to put the hot water in the cup.